Alan works for FICA, and I believe he is managing their major decision management products. And but Alan also well known as an author of, for example, decision requirements diagram, inventor of these diagrams. He is author of several books in business process management, decision management, and he also is a co-chair of DMN revision force and the revision task force, and so he is really active in this movement, in our movement. But what makes difference always, Alan looks on all these activities not only from technical perspective, but always from human perspective. Even when we talk personally during previous decision camps, we always consider how does it affect our everyday life. Are we on the right direction from ethical perspective, from other perspective? And that's why Alan's presentation always brings these human elements to decision camp. And I expect to hear something similar, especially in the era of AI. Alan, take over.
Thank you, Jacob. Well, excuse me, I'm a little bit hoarse.
It's okay.
Okay, today I'm not going to talk about decision intelligence technology as such. I want to talk about how we talk about decision intelligence, in particular, what viewpoint we adopt when we talk about decision intelligence. For example, we hear the word ecosystem a lot. We've heard it in 3 presentations already today, I think, when people are talking about information systems. But of course, this term is borrowed from the life sciences, particularly biology and ecology, and it's used in IT as a metaphor. Now, our choice of metaphors is important because they shape the way we think. They provide us with pre-packaged sets of concepts and relationships, and they allow us to apply these in other domains. So a well-chosen metaphor can be a very useful thing. The word ecosystem in particular is a powerful metaphor because it captures a very complex set of concepts. The better we understand those concepts, the more value we can gain from them when we apply them as analogies. But of course, most people in IT aren't biologists, so we should expect that some of the nuance of the term will be lost in translation. What actually is an ecosystem, and what can it tell us about how to build decision systems? Clearly, to understand an ecosystem, we have to understand something about ecology. I said I was interested in the viewpoint we adopt when we talk about decision making. In this talk, I will be proposing that if we want to address ecosystem enablement seriously, we should adopt a genuinely ecological viewpoint. So in the first part of this talk, I'm going to take some concepts from the life sciences, particularly biology and ecology. I'm going to investigate the original meaning of those concepts in those disciplines and see how they might be used as helpful analogies in IT. Then in the second part, I'll ask what implications these analogies have for the direction of our industry. Since in this forum, we're interested with intelligence, in particular in the form of knowledge-based decision making, I'm going to focus on 4 concepts: cognition, play, culture, and finally, ecosystem. Life, the phenomenon of life, can be understood as autopoiesis, the process of self-creation. Even the simplest organisms, single cells, have a boundary that separates them from the rest of the world. The processes going on inside the boundary create and maintain the boundary. In fact, the processes occurring in the cell create and maintain all the structures in the cell. And then it is those structures that carry out those processes. So we have a self-perpetuating cycle in which the organism continually makes itself. This diagram is from The Tree of Knowledge, a classic work by Maturana and Varela, who describe cognition from an ecological viewpoint. The circle represents the self-creating organism interacting with its environment. This cycle cannot be fixed because the environment changes. The cycle must respond or adapt to the environment. The organism changes, remakes itself so that it survives. This is what Maturana and Varela called structural coupling. The organism is said to be structurally coupled to its environment. They stress that in this model, cognition is not the representation of the world within the organism. Cognition exists in the adaptive feedback loop between the organism and its environment. The example I have here is a copepod. Copepods are small planktonic crustaceans. They're zooplankton, that is, they're animals, and they eat phytoplankton, which are drifting plants. Very efficient grazer. It eats hundreds of thousands of phytoplankton per day. It has a single compound eye, which it uses to jump out of the way of predators. Copepods have an interesting behavior called diel vertical migration, or DVM, which basically means that they go up and down in the water on a daily basis. In the light, processes in the copepod convert oils to fats. The fats are heavier than oils, and the animal sinks down into the ocean. In the dark, the opposite happens, and the copepods rise back up to the surface. So the sun goes up and down, the copepod goes up and down in synchrony. This is a structural coupling. It works for copepods because they're less likely to get eaten by fish that feed in the surface layers in daytime. This really is the sense in which copepods know about day and night. Their behavior is adapted to that daily cycle. It's governed by a cognitive feedback loop. Now, that example involves the organism changing its basic biochemistry, but over time, a more rapid and more flexible form of adaptation has arisen, the nervous system. Nerve cells allow for rapid transmission of information across the organism. Even this copepod has a rudimentary nervous system. But once information processing and response are delegated to a nervous system, it allows behavior to be much more adaptable. The nervous system becomes a specialized structure for learning. In effect, it physically encapsulates knowledge. This allows autopoietic adaptation to occur rapidly without having to change the organism's basic biochemical processes. And hence the additional cycle on Maturana and Varela's diagram. But note that a brain, or indeed any type of nervous system, is not required for cognition. Cognition is certainly not restricted to human beings. It is a necessary feature of any organism that is adapted to its environment. So now I want to see how well these concepts apply by analogy to a higher level entity, the enterprise. How reasonable is it to talk about the cognitive enterprise? Regardless of the intelligence of any particular component of the enterprise, AI or human, is the enterprise as a whole a cognitive entity? Well, an enterprise is certainly autopoietic. The behavior of the enterprise is determined by its processes. In a very real sense, you could say the enterprise is its processes. And those processes build the structure of the enterprise. The enterprise is structurally coupled to its environment through information feedback loops. And the enterprise survives by changing. It adapts its processes to survive in its business environment. So by Maturana and Varela's criteria, a successful enterprise is cognitive. Most of the things described as cognitive in marketing literature are not, to be frank, but an entire enterprise is. It is in a cognitive relationship with its environment. Of course, that doesn't necessarily mean it's conscious, but that's a conversation with a virtual bar. There is, however, at least one important difference between a biological organism and an enterprise. The adaptation of processes in an enterprise is not driven blindly by random variation and natural selection. It is directed by the values of the humans in the enterprise and the humans in the enterprise's business environment. And I'll come back to this when we talk about culture. Play. This is a very widespread animal activity, and it's not immediately obvious why. Why do animals waste so much energy and time doing things which have apparently no immediate value? Amongst biologists, play is widely seen as preparation for survival, learning a repertoire of skills for predation or escape, socialization, and practicing fine motor control. It uses the flexibility of the nervous system effectively to shift the burden of adaptation from the evolution of the species to learning in an individual during the life of the individual. In fact, the period of playfulness in most animals tends to correspond with the development of the cerebellum, which is the part of the brain at the back here responsible for fine motor control through adjustments to sensory motor pathways. So play is a safe way to learn motor and mental skills in a wide range of situations. I've chosen lambs as my example here. I keep sheep, and a lot of my neighbours keep sheep, and in the spring I love to watch these animals chasing each other up and down the croft, running, jumping and kicking. Why do they do this? They do it because they're herbivores, and they need to learn these skills before they're actually chased by predators. Can we talk about an enterprise being playful? Of course, it's a cliche to say that the enterprise must constantly innovate. We have a recent term, disruptor, to describe an enterprise whose innovation is profound enough to change a whole market. But just to survive, enterprises must innovate in smaller ways all the time. There's a whole field of innovation management techniques, including brainstorming, ideation, and prototyping. They even have their own standard, ISO 56000. I liked Dennis's Gen AI augmented ideation tool earlier. But there's a common theme throughout these techniques. They encourage safe exploration of new ideas. Basically, they see work as play, and they see play as a valuable thing. In an augmented enterprise, one where humans and AI agents collaborate in decision making, this play has to include experiments on automated decision strategy using simulation and learning. Note that a common feature of many learning systems is that they are stochastic. Some randomness is required in order to find solutions. The enterprise must explore a space of possible behaviours that's much larger than what it can afford to carry out in real business interactions. It must do so, it must try these things out safely. It must play. Culture. When biologists talk about culture, they are referring to behaviours transmitted between animals through social learning, through imitation or deliberate teaching. We've talked about physical adaptation by evolution and individual learning from trial and error. Culture is a third way, a third level, if you like, to collect a repertoire of adaptive behaviours. It provides for even faster propagation and adaptation. Richard Dawkins coined the idea of the meme by analogy to a gene as a unit of cultural transmission, a form of knowledge transmitted within social groups or more widely within a species. And then he defines a culture simply as a set of memes. For my example here, I'm using chimps, obviously. Primates in general are well known for their use of tools. Chimpanzees' use of tools is known to be socially transmitted. That different troops of chimpanzees display specific habits which are different from other troops. Here in this picture, one chimp is using a stick to fish termites out of a nest, and a younger one is watching and learning. But there are many other examples of culture across the animal kingdom. Orcas, for example, often catch seals by intentionally beaching themselves on land or on icebergs, and orca mothers will actually push their young onto land and encourage them to eat the prey they find there. Some bird song is cultural. Birds learn patterns of song from other birds, and different subpopulations of birds will have different dialects of their song. Same applies to birds' foraging behavior. Even fish can learn their migration routes from other fish. These species have, as it were, moved their knowledge into the cloud. Cultural knowledge will determine whether an individual survives or not. Conservationists know that after a breeding program, you can't simply release an animal into the wild. You need to ensure that it's learned the necessary skills for survival. So culture is hugely important to the success of a species. The success of Homo sapiens can be almost entirely attributed to culture. It's the defining feature of our species. The scale and importance of human culture has increased by orders of magnitude with the invention of language, writing, printing, and now the internet. These are all mechanisms for making memes easily accessible and consumable. Now, I don't think anybody would argue that an enterprise has a culture. I'm using the phrase cultured enterprise here rather than enterprise culture because enterprise culture is usually used to describe styles of management, whereas cultured, in my mind, implies the possession of cultural knowledge. I tend to judge how cultured somebody is by the number of books they have on their bookshelf. My wife disagrees, but then she thinks that she thinks it's clutter. But then she has hundreds of musical scores, so I don't take any notice. You might think organizational culture would be studied under the field of knowledge management, but this focuses specifically on human knowledge, and we want here to address the augmented enterprise. Remembering the biological definition of culture as a repertoire of behaviors, that is, interactions with the world, it is expressed in enterprise processes, including automated ones. So the augmented enterprise uses both human and automated decision making. And as we know, automated decision making depends on knowledge encapsulated in a form that can be executed in automated processes. So a cultured enterprise, in my view, is one that fosters the accumulation of both human and artificial knowledge as cultural assets and deploys them in its decision-making processes. One important aspect of culture that I referred to earlier is the sharing of values. Last year I described how human values can be expressed as performance measures with targets and attached to decision-making processes as explicit goals. So these measures and targets too are cultural assets, shareable within and between enterprises. I'll come back to that. So now I get to ecosystems. Let's look at a real ecosystem. This picture is one of my holiday snaps. I spent some time in the Amazon jungle a couple of months ago. Returning to Maturana and Varela's depiction of cognition, they show that two organisms interact through a structural coupling with each other, which is indistinguishable from that between those organisms and the environment. In fact, each organism is part of the environment of the other. Even in this picture, you can see that plants grow on other plants. Every organism forms part of the environment of other organisms. Functional couplings are of many types. They develop wherever one organism provides something of value to another. One stereotypical depiction of an ecosystem is a food chain based on a predator-prey relationship. Parasite and host are functionally coupled, so are two organisms in symbiosis. There are also relationships based solely on the exchange of information within and between species. If you think, for example, about alarm signals, there's a nice example of Diana monkeys, which have specific alarm signals for different types of predators. They are preyed upon by leopards, eagles, and chimps. They have specific calls for leopards and eagles, but when they see chimps, they keep quiet and they use gestures because chimps will focus in on their calls, and it doesn't do them any good. But if the chimps warn each other of the presence of leopards using their own calls, Diana monkeys will respond with their own leopard warning call. So information being passed between members of one species constitutes part of the environment of other species. And I've already talked about the exchanges of knowledge that constitute a culture. If we think of all these complex interdependencies in the horizontal plane, complexity also exists in the vertical dimension, because systems are composed of other systems. Each organism is a system of cells, each cell is a system of organelles, and going upward, the organism may be part of multi-level societal groups. As a result, any biological ecosystem is unimaginably complex, and it can only exist through the continual adaptation of all its components. The ecosystem is a network of components all constantly adapting to each other. So finally, let's see how these concepts illuminate our understanding of an ecosystem of enterprises. Two enterprises are functionally coupled if they depend on each other for business. A cognitive feedback loop exists between them, such that each enterprise is part of the business environment of the other. Every enterprise provides opportunities for other enterprises. Couplings develop whenever they provide business value to another enterprise. Many types of relationship, competitive and cooperative, exist. The supply chain is based on networks of provider and consumer relationships, which is very reminiscent of the food chain. But of course, there are many other forms of relationship, including exchanges of information and knowledge. The resulting ecosystem is what we call the economy. And again, that is just the horizontal dimension. In the vertical dimension, we have systems within systems again. I've described before at this conference how a decision-making enterprise is a network of decision makers. And enterprises are organized into decision-making groups in various ways at multiple levels. So there is no such thing as a simple ecosystem, even when we're talking about an ecosystem of enterprises. In order to survive, an ecosystem has to be complex, and all of its components have to be adaptive. Okay, so those were the analogies I wanted to draw between biology or ecology and enterprises. The point of drawing analogies is that they have useful implications. So my question is, what lessons can we take from this ecological description of the enterprise ecosystem? Let's start with the observation that ecosystems are very, very, very complex. This means they cannot be created from scratch, and their behavior cannot be precisely managed. Here's an example of an artificial ecosystem. This is my fish tank. I haven't created this ecosystem. I assembled it from components that were already extremely complex. I provided the tank and the water. I introduced plants and fish that were already adapted to a certain ecology. These component organisms then create their own ecosystem. I cannot even manage this ecosystem in detail. I can't determine the behavior of the plants or the fish. The plants will do what the plants do and the fish will do what fish do. But I can tend it. I can provide it with heat, light, aeration, a bit of food, although not as much as you might expect. I can remove debris and so on, just to ensure that the ecosystem flourishes. We are interested in setting up an ecosystem of decision-making enterprises. How can we assemble and tend a knowledge-based ecosystem? How can we provide an environment that will make that ecosystem flourish? So to give structure to my answers to these questions, I'm going back to Maturana and Varela's diagram and relabeling it to describe enterprises. This depicts the enterprise as a set of adaptive processes interacting with the world and with other enterprises. Note that the relationship here are symmetrical, so I can just focus on one enterprise and just talk about all the others as other parts of its environment. First of all, let's reify the processes. So the cycle now represents the adaptivity of those processes. The behavior of the enterprise at any time is determined by its processes. The processes build and maintain the enterprise. They also manage all the interactions between the enterprise and the world, and all the interactions between the process and other enterprises. How do these interactions occur? Increasingly commonly, these interactions occur through services. Other enterprises expose their processes as services, which are accessed through a common mechanism, APIs, and made available typically through digital service platforms. This diagram now describes a basic enterprise infrastructure, which already exists and has been hugely successful. Service platforms are often described as ecosystems. In themselves, they are not, but they certainly have the potential to support one. But as in the biological realm, we want to add layers of functionality that will improve the adaptivity. How can we assemble a knowledge-based ecosystem on top of this infrastructure? How should we tend it? I'm going to build this diagram out and collect some requirements as we go. As a bare minimum, it must be quick and easy for enterprises to create processes and manage them over time. Developing processes from scratch is notoriously slow and labour intensive. The speed of delivery is already greatly accelerated by service platforms, but we can go further to reduce the time to value by assembling processes from existing assets. Process models and decision models for common domains of decisioning, data models for common objects in those domains, and especially business knowledge models, common knowledge in the form of rule sets, analytic models and algorithms. When assets like these are shared, they constitute a culture. They're shared within an enterprise, they improve consistency, they reduce rework, they improve agility. Shared across industries, they align enterprises, enable governance, and avoid reinventing the wheel. These assets therefore have business value. This will support further interactions in the ecosystem based on trading of that intellectual property. They also have cultural influence. Governmental organisations, business consortia, standards bodies, user communities, all will want to share or enforce best practice. But how do we ensure that the shared assets will fit conveniently together? We will not achieve faster process delivery if these components all need bespoke integrations. We need a common approach to ensure composability. Here is the central value of decision modelling. It exposes the natural structure of a domain and encapsulates knowledge in independent, composable business knowledge models. So the use of decision requirements analysis and model-driven authoring are not just nice-to-have methodologies, they are essential to the creation of an effective enterprise culture. Having created them, our processes must be highly adaptive and learn from their interactions with the world. What can we do to help this? Well, there are two important points I want to make. The first is we cannot and should not attempt to use enterprise processes that learn and adapt as a single black box. We need to use decomposition to separate concerns. It's like a nervous system, we don't want to adapt everything. Decision requirements analysis and decision modelling ensures that knowledge is encapsulated in business knowledge models, as I said, and efficient adaptation can be achieved by restricting learning to those individual business knowledge models. As I discussed last year, this is my second point, learning must be based on performance feedback, with performance measured against explicit KPIs that represent the values of the enterprise and of wider society. To support shared values, we can provide libraries of shared KPIs and targets. Those targets can be both business goals and environmental, societal and governance goals. Our enterprise culture now includes shared human values. More and more enterprises are realizing the value of safe experimentation using digital twins and simulation. A sandbox is essentially an artificial world, so I've drawn it up here as a limited reflection of the real world. When a simulation facility is integrated with authoring and learning functionalities and given access to a sandbox, the enterprise can experiment virtually risk-free, with new behaviours before trying them out in limited ways in the real world. As I discussed last year, experiments can be invented by humans or by AI, and I rather suspect that AI may be better at noticing which spaces of behaviour are unexplored and suggesting experiments designed to investigate those areas. We could even imagine multiple enterprises using a shared sandbox to experiment with new ecosystem interactions and novel business models. Business stakeholders and AI components can now play together to explore new business behaviours. In this world, work as play is not just a mindset. It's incorporated into the structure of the enterprise decision management infrastructure. So finally, collecting together all these lessons from life, we have an 8-point vision for a knowledge ecosystem that goes well beyond what can be achieved through service platforms alone. In the field of cognition, we need to scope learning to individual business knowledge models. We want to define enterprise motivation as explicit KPIs and provide feedback on the performance against those key KPIs. We want to encourage play by providing a simulation sandbox for digital twins, integrating authoring and learning with that sandbox, and we want to allow both humans and AI to propose experiments to be carried out in that sandbox. And we need to foster a culture. We want to allow decision and KPI assets to be shared and traded, and we want to ensure composability through decision requirements analysis and model-driven authoring. None of these ideas are new, of course, and they won't be very surprising to anybody who knows me. But what the ecological viewpoint does is explain how these things are related and why they are important. You cannot enable an ecosystem just by connecting its components together. You also need to enable the adaptivity of its components, its ability to experiment safely, and the abstraction of its cultural knowledge. So in conclusion, what can an ecological mindset help us to achieve? I believe it can help us create a flourishing ecosystem of successful, agile enterprises directed by shared human values, supported by evolving resources of proven decision assets in which individual stakeholders feel empowered and have space to play. I think this vision is worth pursuing. The potential business value is immense, and also it would be a happier world. There. Time now for questions, I hope, or just your thoughts. Let's make this an open conversation.
Okay, great. Thank you very much. Very, very interesting. Okay, we do have one question I can see so far, but probably people would ask more in chat. By shared sandbox, you mean the digital twin? I mean the environment in which the digital twin works, yes. So the system of data record and so on, which the simulations that are the digital twins interact. Okay. More questions, please. Denis?
Yes, hi, Alan. Thank you for this very, very thoughtful presentation, as always. This is a very great brain teaser. One place where I'd like for you maybe to expand is when you presented culture in nature and in a natural system to be a lot about imitating others, but when you took it down to system, you reduced it to KPIs. Is that just as a way of thinking, you only manage what you measure, or is that just an early reduction? I'm trying to think that there's a lot more factors. As we all know, you and I have both been in business for many years, And just managing a company by KPI doesn't get us anywhere. You become what you measure, basically.
Right, okay. No, I certainly didn't mean that all of the cultural assets were KPIs. In fact, I was really mostly talking about things like process components and decision model components, including business knowledge models, data models, and so on, that are continually reused across domains. But I wanted to point out that KPIs, in other words, ways of calculating particular types of performance measure, do exist in standard forms across domains and business areas, and can be reused as assets, even if the target values that enterprises aim at are different for different enterprises. So that would be, as you say, the style or the bias of the enterprise would be in setting its targets. But there's I think a great deal of advantage to be had in sharing the definitions of KPIs.
Yeah, I agree. And there are many efforts of standardizing KPIs across different industries, so we can actually compare and speak from the same page, basically.
Absolutely. So we see ontologies of KPIs, and you can go online, you can download these things in vast numbers, and ideally, yes, we should be able to do that into our decision systems.
And where, so along the same line, sorry if I'm monopolizing, along the same line, where does ontologies and knowledge graph come to play in there, or are they just a way to capture things?
Yes, they sort of form a layer above what I'm talking about, don't they? They define the structure of the assets and how they compose together. So the knowledge graph is really just another way of expressing the formal rules around those components
To help you, here's what I would suggest. I would suggest that all reuse must be based on some common ontologies and graph of knowledge. That's what gives you the basis for reuse, whether it's reused by copy or by reference, by having this into a common uniform view of the organization. Yeah.
Absolutely. And really, standards like BPMN and DMN are just ways of hiding the ontology, so that you get that by default when you adopt the standard.
Yes. Thank you very much.
Okay.
Great presentation.
Okay. Alex, go ahead.
Hi, thank you for this presentation. This was phenomenal. I'm curious, when you start defining ecosystem, where are your thoughts as to where does it start and end? And so you use the analogy of the sheep and the monkeys and then the rainforest, but maybe putting that into thinking about it from a business perspective, or maybe we can still use the analogy of the rainforest. Where do you think of it in terms of it starts and it ends? I don't know if that makes sense.
A really good question, and I'm not sure there is a technically correct answer to that ever. How do you define the beginning and end of an economy? You look at any particular section of it or subset of it which is of interest to you. We're in this forum, we're interested in ecosystems of enterprises that do augmented decision making, and so that's what I was addressing in the talk. But
yeah, no, I know that's why I'm asking. No, and that's why I don't know if this is the right question to ask, but I was just kind of curious in the model that you were presenting, and that's, I work in supply chain, and whenever we're presenting these type of concepts out, we always struggle with, I think you made a joke about something about bold marketing or something like that, which I thought was funny, because where does end to end, or where does something start and where does something end in the idea of an ecosystem? or platforms or whatnot. And so it's just kind of, and that might be a discussion point for later, but I was kind of curious so anyways, that was just some initial thoughts. It might be more of a thought than a question, but thank you.
Yeah, it's a good thought, Alex. And I think practically what happens is that these conversations are led by software providers who are building systems to support enterprises, so that they talk about the ecosystem which is supported by their products, which sort of is a rather limited scope, but that's the normal area of discourse. It makes it much easier.
Yeah.
Okay, do we have more questions? Okay, Elena, go ahead.
Yes, I have a question about the processing between two different companies about the digital platform. How you will enforce or your offer, how it will be possible to enforce to use some common platform for different companies, because usually companies trying to bring everything to their side and enforce other companies like their third parties to use their system, and there is endless battle with this. Thank you.
Absolutely right. And you can't force anybody to use a platform or an infrastructure. All you can do, if you're interested in being one of the providers of something that supports an ecosystem like this, is to make it worth people's while. So it'll be down to business value at the end of the day as to what the benefits are of riding on one system or another. And I expect it'll be the platforms which win out will be those that provide the most complete functionality.
Okay, maybe I should use the word encourage, but in the battle between companies, which I usually saw, it's that every part trying to force other part to go to their side.
Yes.
Thank you.
Yes.
Okay. Do we have more questions? Or? I just want to make a comment that, as usual, the most quiet person creates the big revolutionary, shares the big revolutionary thought that more aggressive people from technical world. And Alan is one of the most well-known experts in decision management. And I just try to calculate how many times Alan used the word decision, and almost nothing. And it was a little bit surprising. And he's actually used the first time in this context the word knowledge model. Maybe that's where you feel we're all moving. It's not necessarily about AI hype, but it's more about sharing and understanding humans and our experience and our knowledge and intuition. And maybe even you coming closer and closer to what Ron Ross trying to promote for many, many years. What would be your comment?
Well, you knocked me sideways with your last comment there, Jacob. Before you got to that, I would agree with you that I think that we're moving towards an era in which the definition of human values will be more important than the definition of the decision logic, although there will always be an important role for very clear, defensible decision making. The reason I didn't talk about decisions very much was that I was stressing the interactions of enterprises with their environment, which is controlled by processes. And there's decision making going on in those processes, but actually you don't need to mention it to talk about the intelligence of the processes. So it's more by neglect than a deliberate choice there.
Okay, we should not force Dr. Moore to wait. He would ask his questions. Bob, go ahead.
Yes,
Sorry?
Yeah, go ahead, Bob. Nice to see you.
No, it was fascinating stuff, Alan. I was putting together a presentation on free will a few weeks ago for my philosophy group, and reading through books where we're kind of talking about the developmental process of how interactions work. One of the things that strikes me about trying to do the ecosystem thing, though, is the way that enterprises interact with one another, kind of at the high level, is very much by the senior management, who seem to know very little about the processes that go on in the organizations that they run, or at least one gets that impression. So I'm kind of wondering whether you can think of any examples of enterprises which are actually trying to tend to their ecosystem in the manner in which you said that we need to.
No, I don't think there are any, Bob, which is why I'm talking about it.
I had a feeling you were going to say that.
Yeah, I mean, there's a big gap, I think, between definition of business models, which use financial modeling and KPIs and so on, and the execution of decision making that actually carries out those or tries to achieve those goals, and we need to connect them together. And at the moment, business stakeholders don't really have an easy way to express themselves in the sorts of systems that we are typically putting together in this forum. They're not interested in specific decision logic. They're interested in defining the targets, the goals.
They're interested in making
money. For example, yes, but many other things as well.
Yeah.
Okay, we should move forward, and I want to tell everybody that Ellen would be tomorrow among panelists on our panel at 14:00 p.m. And it's a panel called Ask an Expert, and you would be able to hear more from Ellen, or just you can type your questions in chat and Ellen would probably answer. Okay, thank you very much. It's really interesting presentation. So
thank you.
Thanks, Alan.
Okay. We have